Welcome back. Today we're going to talk a little bit about the coordinate plane and doing some operations in the coordinate plane that involve some common formulas that we've been using for a really long time. So this is going to be largely review. That's why it's in the prerequisite section. First of all, let's talk about the coordinate plane. The coordinate plane was also known as the Cartesian plane, is named for René Descartes, who wrote about the plane in 1637. The way the plane is organized is grid lines that run vertically and horizontally to help it locate coordinates in the plane and put things in neat and orderly places on there. So when we talk about the origin, as you hopefully recall, is at 0, 0. That's the dead center. That's where the x and the y-axis intersect. The x-axis runs horizontally, and the y-axis runs vertically. When I talk about points, the x-axis and the y-axis are actually number lines. And so if I start at 0, 0, if I'm moving to the left on the x-axis, that's negative. If I'm moving to the right, that would be positive. Up on the y-axis is positive, down on the y-axis is negative. And so to locate a point, all I simply do is use my x and my y, they're conveniently in alphabetical order, to try to find that point by stepping along those two number lines that we have here. So I start at 0, 0, and I'm going to go -6, so backward 6, and then up 4, 1, 2, 3, 4, and so here's point P. We would label it with the letter P, and just for good measure, I'm going to go ahead and label it with its number as well. Point T is at 3, 1, and so it's going to be at 1, 2, 3, and then up 1, so this is point T at 3, 1. My quadrants is divided into 4 quadrants. The quadrants tell me exactly where, so they give me generalizations. For example, so over here, this is quadrant 1, and it seems silly to start in the upper right hand, but if we think about exactly what's going on there, all of my coordinates in this one are positive, positive. So my x is positive, my y is positive. From there, we're going to move around counterclockwise. So this is quadrant 2. In quadrant 2, my x is negative and my y is positive. In quadrant 3, both are negative. And in quadrant 4, I've got positive x and negative y. Okay, so just those generalizations help us think about where these points are going to be located if my answers are reasonable, and start to look for generalizations in math. Being able to take a bunch of information and think about it in terms of what it has in common is very important in mathematics. All right, that all being said, that was a review of the coordinate plane. Let's talk about 4 formulas, and we're going to use a couple of them to help us understand and review this section. First of all, the Pythagorean Theorem. Seems somewhat disconnected from what we've been talking about with the coordinate plane. But if I think about a squared plus b squared is equal to c squared, I know that a and b are my legs of my right triangle. So this is for a right triangle. Hopefully you don't mind me drawing a little triangle there. A and B are the legs, and C is the hypotenuse. And the hypotenuse is the longest side. Well, when we start to move into the coordinate plane, what we're going to realize is the Pythagorean theorem is actually super applicable to the coordinate plane because the distance formula is based on the Pythagorean theorem. The distance formula, I like to refer to it as the unknowable formula because we start to talk about, well, it's x2 and y1 and squared, do I add? But if you think about the general form of the Pythagorean theorem, what we have is a distance squared plus a distance squared is equal to my hypotenuse squared. Well, if I think about, these 2 points here, up here that I had, like P and T, I could find the distance between them. Well, I would use, a certain formula, or I'd use the distance formula, and I'd try to figure out exactly what was going on. But ultimately, what can happen here is, if I am operating under the assumption that everything is on a grid, check out what happens here. The distance between P and T is actually, you can form a right triangle. And so if I sort of think about this as like A and this is like B, my hypotenuse, which is the distance between those 2 points, is actually C. Well, now the distance formula starts to go from this formula that I need to know to, oh, wait a second. Well, if I think about the length of A, check out this length A here. A is actually it's only measuring x values, right? It's side to side. And so my distance, my length of A is from -6 to 3. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, because it's from x equals -6 to 3. Well, think about what that means just for a second. If I'm finding the length of a leg, I'm distilling my coordinates into just x's and y's. And so my distance is going to equal something like this, x2 minus x1. Well, look at what I just did there. If I take 3, which is my x2, and I subtract -6, that would be 9. Well, that doesn't come from nowhere. That's the distance between the 2 points. Well, let's say for a second that you used your p as x2 and your t as y1. So -6 minus 3 would be -9. Well, when we square that value, it takes out the negative because I'm talking about a distance, right? And so if I start to think about where the distance formula comes from, it actually comes from x2 minus x1, which tells me the distance between the x coordinates, square it to get rid of that negative part because it's a length. y2 minus y1 is the distance between the y values, square it so that we take care of that negative part. And then it's a square root because if I didn't square it, or if I didn't unsquare it, if I didn't take the square root, I'd have a squared plus b squared is equal to c squared. Sorry, I forgot to put that there. So c squared. So to find that distance, I actually need to take the square root because that's going to give me the length of the value. So the length of c. Okay? As always, when we use the distance formula for this section and sections going forward, we need to put it in reduced radical form. So for example, the square root of 28 can be equal to the square root of 4 times the square root of 7, so 2 square root 7. Okay, so that's actually what I'm looking for you to be able to do, is to pull out reduced radical form. All right, that was a pretty long explanation, but I need you to see that the Pythagorean theorem and the distance formula are related. The distance formula doesn't come from nowhere. Midpoint formula. It is the average of the coordinates. So I've got x2 plus x1 over 2, comma, y2 plus y1 over 2. It's the average, so take the x's, add them together, divide by 2. It's the average, so the middle of the x coordinates, and the y's added together, divided by 2 gives you the average of the y coordinates. In a circle, we're going to have with h comma k as the center, so we're in the coordinate plane, and a radius equal to r. And so my standard form equation is x minus h squared plus y minus k squared is equal to my radius squared. Okay, that's what we're looking at right now. So the standard form equation is x minus the x coordinate of the center squared plus y minus the y coordinate of the center squared equals radius squared. Okay, so this was an activity that we're going to do in class. It's ordered pair speed dating. So I'm going to pair up people. They're going to have different points. They're going to find the midpoint and the distance. I'm going to give you 2 examples here to allow you to do. I'm going to show you one, then you're going to have one that you can do. Let's just say, for example, that one of you had 1, 5 and the other of you had 6, 2. Okay, and so the goal was to find the midpoint and the distance between those 2 points. One of the stipulations of the activity was the point that you are has to occupy the x1, y1 space. So you're going to, hopefully what you see is, it doesn't matter if you put x1 first or y1 first, you should get the same answer. x1, y1 first or x2, y2 first. You should get the same answer. So what we're going to do is we're just going to find the midpoint and the distance. So if it helps you, x1, y1, x2, y2, you can label them if that helps you. So I'm going to add up my x coordinates. So 6 plus 1 over 2 and 5 plus 2 over 2 is going to give me 7 over 2, comma 7 over 2. You can leave it as a fraction. Sometimes my math lab will ask you to do that, or you can write it as 3.5, comma 3.5. It's important to remember a midpoint is always just that. It is a point. Don't give me a distance. It's not going to be a distance. It's going to be a point, x and a y. Distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay. So we've got 6 minus 1 squared plus, so 6 minus 1, 2 minus 5 squared is equal to 5 squared plus 3 squared is equal to the square root of 25 plus 9 is 34. And that is actually already in reduced radical form. So my answer is square root of 34. How did I know that this was already in reduced radical form? Well, let's see. To determine reduced radical form, you're going to try to divide by perfect square. So I know 36 doesn't go in, so I'm going to start down from there. I know 25 doesn't go in. I know 16 doesn't go in because twice that would be 32. I know 9 doesn't go in because 9 times 4 is 36. I know 4 doesn't go in because 4 times 8 is 32. 4 times 9 is 36. Okay, so that's my reduced radical form. Here's one that you can try. So go ahead and try this one. And 3, 7. So try it, show your work, and what's going to happen is after you pause, I'm not going to pause, but you're going to pause, do that problem. After the pause, I'm just going to give you the answers, okay? All right, so you're back after the pause. So hopefully you paused and did these. I'm going to give you the answers right now. The midpoint should be -1, comma 4.5, and the distance should be the square root of 89, and that's already in reduced radical form. All right, next one. Moving on. We're going down to part 2 here, where the notes say part 2. So in class, we would have done 3 more examples, a little bit of speed dating action. Right now, we're going to work with shapes. So we have the standard form of equation for a circle, and then we're going to find perimeter and area of a triangle in the coordinate plane. First of all, I like to write down the formula first. And so for my standard form of a circle, x minus h squared plus y minus k squared equals radius squared. Well, the cool part about this is they already gave us the radius. So sometimes they're not going to give you the radius, and they'll give you maybe the center and the outside, so you have to find that distance. But in this one, they did give us the radius. And so all I'm doing is I just really have to plug in the stuff to the formula. My center is h comma k, so I've got x minus a -4, so that'd be x plus 4 squared plus y minus 1 squared equals 64. Done. That's it. Okay. So go ahead and try the next one. I think you're going to find that it's fairly straightforward. After the pause, I'll do it for you. So go ahead and start that one, and then pause, do it, and then I'll give you the answer when you come back. Okay, so you're after the pause. You tried this one. It should be x squared plus y squared equals 25. And the reason why that happens is because my radius is 0, 0, so it's a circle centered on the origin with a radius of 5. Okay? All right, finding perimeter and area. Here's something pretty cool. Let's first, I gave you this coordinate plane, so you can draw it in. You can kind of see what's going on. It helps me to sometimes put them in the coordinate plane. We've got the beauty of technology. We can kind of draw a lot. We've got graph paper at our fingertips. So I'm going to do -5, 3. So 1, 2, 3, 4, 5. 1, 2, 3. I didn't label these in the example. You can. I'm going to. A, B, and C. It's going to help us for reference. So there's A. And B is at 0, -1. So it's down here. And C is at 4, 4. So 1, 2, 3, 4. 1, 2, 3, 4. Alrighty. So here's my attempt. That's not a bad straight line, right? That one's a little rougher. Okay, so that's a triangle. Perimeter and area. Hopefully you remember from geometry and other studies that perimeter is the distance around the outside. So perimeter and area are going to be 2 different things. Well, to do any of this, right? So perimeter is the distance around. And the area, if you remember the area, the formula for the area of a triangle, it's 1/2 the base times the height. So we have to figure out what the base and the height are, and we need to figure out what the lengths of the sides are. Well, lengths of the sides is what we just did. So we're going to do the lengths of the sides. I am going to start with AB. And the length AB is the square root of, so I'm working with these two here. I'm going to go x2 minus x1, so 0 minus a -5, so 0 plus 5 squared, plus -1 minus 3 squared. And so what I've got is the square root of, this would be 5 squared, so that's 25. This would be -4 squared, which is 16. So the length of that side is root 41. I can't really reduce it, but I'm just going to leave it like that for right now. We'll reduce at the end. If I need to reduce, I will reduce at the end. Okay, so that was AB. So this is root 41. Okay, so I'm just going to keep going. So AB was this. So now I'm going to go BC. I'm just going to go straight around the circle, or sorry, the triangle, keep everything straight. BC. So I'm going to have 4 minus 0, which is 4 squared, plus 4 minus -1, so that'd be 4 plus 1 squared. And that's going to be 16 plus 25. Oh, that's pretty cool. All right, 41. And so at the very least, I know these two sides are congruent. So congruent means they're the same size, same shape. So these two sides are congruent. They have the same length. They're equidistant. That doesn't necessarily make it a right triangle, but that's pretty cool because it's isosceles. Let's find the length of CA. And I said CA because I'm going this way, so CA, that's just me being mathy. So here we go, CA. So that's minus a -5, so 4 plus 5 squared, plus 4 minus 3 squared, which is going to be the square root of 9 squared, which is 81, plus 1 squared, which is 1, is equal to the square root of 82. So, what are we going to do now? Well, I can find the perimeter pretty easily. My perimeter is equal to the sum of all three sides. So what I'm going to do is, I'm just going to say my perimeter is the square root of 41 plus the square root of 41 plus the square root of 82, which is equal to 2 square root 41, because I have two of them. I really just wrote 80. I'm sorry, 82 plus root 82. Sorry about that. So my perimeter is the two lengths of square root of 41, so 2 square root of 41 plus square root of 82. My area, here's what's tricky, is I don't necessarily know the height of my triangle. What would be really convenient is if it was a right triangle, right? So if it's a right triangle, you remember it like just a general right triangle here. This would be the base and this would be the height. So let's test to see if this is a right triangle. Is it a right triangle? Okay, so to test if it's a right triangle, we're going to go leg squared plus leg squared is equal to hypotenuse squared. Well, how do you know? This one's the longest. So we're going to test that one as the hypotenuse. So is the square root of 41, so leg squared, plus leg squared equal to my potential hypotenuse, my longest side squared. So I'm putting a question mark over the equal sign because I'm asking, is the length of my shortest side squared plus the length of my other shortest side squared equal to my longest side squared? Well, what I end up with is square root of 41 squared is 41, plus square root of 41 squared is 41, is equal to 82, and that checks out. So this is a right triangle, which means that my base and my height are my legs. And so my area is 1/2 41 times 41, because it's the base and the height would be the two legs. So in this case, this would be 41, so root 41, this would be root 41. And so this is 1/2 the base, which is root 41, times the height, which is root 41, which is equal to 1/2 times 41, which is 20.5 units squared. Okay, so my perimeter The three sides, I had to find their length anyway. Area, I found out it was a right triangle, so then I was able to find what the base and the height were and use the formula for that. All right, guys, thanks for watching, and we'll see you next time.